Unit 5, Part 12. So don't worry about Section 4 too much of Unit 5. Unit 4, Section 4 is on mechanical decision procedures. You can read through it once, but you won't be tested on the material of Unit 5, Section 4. So I will do a second example of the short truth table method, and that'll do for Unit 5. This is going to be 3A, example 3A from the exercises. Okay, so once again, I've listed the premises and conclusion. Okay, what am I doing? I'm looking for a counterexample. I'm looking for an assignment of truth values to the sentential variables, which make the premises true and the conclusion false. So looking for an assignment of truth values to the sentential variables, let me make a box. I've got P, Q, R, S, T again. P, Q, R, S, T equals, I don't know yet, but right, I'm doing this, you do this. This is how you go through step by step. Follow what I go through step by step. That's what you do in answering the same kind of question on the exams and quizzes, right? T's and F's will appear here as I figure out which truth values are determined. And if I can find a consistent assignment of truth values to the sentential variables, which make the premises true and the conclusion false, that is my counterexample. And if I cannot find a consistent assignment of truth values to the sentential variables that make the premises true and the conclusion false, then the argument is in fact valid, right? So let's do it. So, oops, I forgot those. The first thing, I draw up the box, list all the sentential variables, and then I make my initial assignment. Remember, unlike the truth tables, I contrasted them last time, unlike the truth tables where you're doing bottom-up computation of truth values, right? Because you're given, for each row, you're given the truth values for the sentential variables, right? Calculating when P is true and Q is true or whatever. You're given those, and then you calculate the truth value for the sub-formulas, and then, when you've done all that, you do the highest sub-formulas, until you can finally compute the truth value of the overall form, right? So bottom up like that. This is top-down assignment, right? I'm saying what I want to get to, where I'm looking to get, is this particular assignment where the premise is true. You must be able to see that that's the major operator of the first premise. What's the major operator of this guy? Of course, this. That premise has to be true and the conclusion has to be true? No, the conclusion has to be false, right? Make the conclusion false, okay? And then I look to see what sentential variables have their truth value determined, have their truth value necessitated by, first, this opening move, okay? Should I start with any premises? No, I shouldn't start with either of the premises for this reason. Both of the premises are conditionals, and because they're premises, the conditionals are made true, and there are several ways, 3 of the 4 ways, to make conditionals true, right? Conditionals are true when you've got true, true, or false, false, right? So too many options, nothing is determined of the P, the Q, the R, and the S, right? Or very little is determined, right? As to what truth values they will be. What I want to get to is determine truth values for specific individual sentential variables. I will start with my conclusion because here I do have the truth value of 2 sentential variables determined. Hey, what? How is that? Because you said it was because these are conditionals you don't want to start with the premises. But here, this is also a conditional. Why are you starting with a conclusion if it's also a conditional when you're not starting with the premises because they're conditional? Pause and answer. Okay? It's because the conclusion is made false, right? So that conditional is false. These conditionals have to be true. This conditional has to come out false because it's the conclusion. Because we're looking for a counterexample, which is all premises true and conclusion false. So conclusion has to be false, and there's only one way to make a conclusion false. P has to be true, right? Now, what has to be false, right? You should all be able to see this. This should be easy for everybody. not T has to be false. Not T has to be false. So the T hook F, right, look at where the T hook F making up the conditional go, right? The T goes above the antecedent. In this case, it's just the sentential variable P, just the atom P, right? So that allows me to put T down here, but I can't write what goes here under this T here down right away, because look, it's false. The conditional is false, so it's T hook F. But what is F is not T, right? It's not T, which is false. See how it's also top down? I've gone from the conditional, the overall, to the whole consequent of the conditional, right? Which is itself complex. It's complex because it's not T. As we stressed, talking about negation, negation is structure, right? It's not simple. Not T is not a simple sentence. It's built with a sentential operator, negation blank. Right, so it's not T, which is false. And now, finally, top down, from the conditional to the not T, now I have finally determined what T is in the third step. Because if not T is false, T has to be true, of course. T must be true for not T to be false, and not T has to be false for the conditional to be false. So P and T are both true by this assignment. Okay, so I go and I make T true here, and no P's or T's, and P true here, right? Okay, so that's what I've got. Okay, moving on, I can see that if I tend to my first premise, I see that R is determined for me. Why? This first conditional has to be true. Why is it so? Because the overall form has to be true, the conditional has to be true. The truth of P appears in the antecedent of the overall conditional. It appears as one of the disjuncts of a disjunction, and I know, application of my knowledge of the truth table of the wedge, right, that one disjunct being true suffices for the truth value of the disjunction, right? Q doesn't matter. I can leave Q undetermined, as I sort of want to do. If I can make this out to be true, satisfy everything that needs to be satisfied to make this true, without assigning to Q, that's good. You want to make sure every step is necessary. Assigning a truth value to Q is not necessary. But P being true here, so that makes the antecedent true, so what have I got? So this is what my thought is. I'm going to write down exactly where my mind is attending to which parts, right? It's true, right, which is the truth value of the antecedent of the conditional, and the conditional is true. So, right, the question mark here, I'm determining what the truth value of R is, right? That's what I'm looking for. I'm looking, this was different from the full truth table method, which was bottom up, because here it's top down. We are seeking, right, the truth value of the individual variables. It's like, right, it's like we're going, right, yeah, this is good. Say this is a row in a truth table. There's all sorts of other rows of a truth table, right? And right, say P, Q, R, ST, whatever. Those are the base columns, right? What do we do for truth tables? We list all the base columns systematically, and then with them, we use them to calculate the truth value of the sentence forms which make up the argument form. The sentence forms to the premises of conclusion. This is the other way around, right? First, we're assigning true, 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 of many premises it is false, right? The terminator assignment. We're assigning the truth values to, as it were, the actual premises in conclusion. And we're seeking these, right? So what would these be? What is my counterexample? What assignment of truth values? Those are the question marks. The values that appear in the base column for the truth table are like the question marks. That's what we're seeking. We're starting with these and seeking these in the short truth table method. Okay? So I've got P and T are true. Okay, so T, hook T, I know that this has to be true, so R has to be true, right? Because T hook false is false. So it's necessary that that's true. R has to be true to keep the first premise true. But look now, look what happens now. R is true, and here is the mind explosion part, right? If R is true, then the disjunction is true, right? But look, I was necessitated in assigning T the value true, which means not T is false, right? There's no way to avoid it. The only way to make the conclusion false is for T to be true, right? So that means this has to be false, but look, it's necessary that R is true, it's necessary that that AND isn't true, so all these are conditions I'm supposed to fulfill, right? T, hook, F, T, right? I have to make a conditional true, I have to make the antecedent true, I have to make the consequent false. That's impossible. Conclusion, there is no assignment of truth values. There is no consistent assignment of truth values to the sentential variables that make the premises true and the conclusion false. Therefore, the argument is valid.